to the cloud. Okay, welcome everyone. So I have copy and pasted a link to the notes document that should be in the chat. So please sign in there if you haven't already. So the agenda for today is we're going to first get started with some announcements, and then I'm basically going to pass it off to Charles and Rachel to run the show with the Pangeo Forge tutorial. So yes, welcome everybody to the ESIP Cloud Computing Cluster session with our special guests, Rachel and Charles, presenting on Pangeo Forge. There's a lot of interest in this, so I'm really excited to have a whole hour, which I'm sure is not even enough, but have a whole hour dedicated to basically getting off the ground with a tool like Pangeo Forge. So I don't have any immediate announcements as far as the ESIP Cloud Computing Cluster goes. I know that AGU Ocean Sciences is going on right now, so there might be a lot of people in the community that are involved about that. But I wanted to open it up to any of the attendees with any announcements that might be of interest to the Cloud Computing Cluster members. If there's specific sessions of the AGU OSM that we should be thinking about joining or listening to, or if there's other events coming up, or submission deadlines that we should be aware of in terms of, continuing to grow the cloud computing cluster community. I want to open up for any announcements.
Yeah, I've got a couple things, Amy. Thanks. So this week I'm running a sprint for CEOS, ARD, and Stack. So the goal, this is going to be 2.5 hours, 3 till 5:30 Eastern time, Tuesday, Wednesday, Thursday. It's an awkward time because we've got people from Australia and Europe and the US and Canada as well. So, but the goal here is to finalize the Stack extension for Card4L and also develop implementations of that in different data sets, Landsat, Sentinel. So really kind of getting to the point where we have a fully characterized metadata for these data sets that in order to see if they're Card4L compliant. And also Planet is going to be bringing their Fusion data and working on that. And we're also going to be working on validators for doing automatic assessment of collection level metadata for Card4L compliance. So if anybody's interested in attending, just ping me, and there's actually a Google form. I can put it in the chat to sign up.
Yeah, that'd be great. I'd be interested to know more about that.
Hey, Matt.
Yeah.
This is Ted. Could you, you're making me feel like ridiculously out of date here. What's Card4L?
Okay, so Card4L stands for CEOS ARD for land, but they're changing the name to just CEOS ARD. And it is a specification for data sets. It's essentially an assessment to bless data sets as being suitable and meeting certain accuracy and processing requirements to make them suitable for generating time series out of. So like the requirement is, it's got to be atmospherically corrected. It's got to be geometrically accurate to within some pixel accuracy. The spectral bands are available. It describes all sorts of metadata that must be present. It's got to be BRDF corrected. There's actually 2 different requirements, just threshold and target requirements. So, so that's it in a nutshell.
Great, thanks.
Okay, any other brief announcements? Also, if you have the notes document open, feel free to add them. Megan, was there anything from the ESIP Monday update that you wanted to highlight?
I put a link in the chat. If you haven't seen the Monday update, that's a good succinct list of the news coming out of ESIP. But I would say if I highlighted one thing, it would just be watch out for more info about the July meeting coming soon. I'm about to put out the call for sessions. Time flies, right? It feels like we just finished the January meeting, but hope you're all getting excited and looking for more info to come soon.
Cool, thanks. Okay, then I'm gonna hand it off to Charles.
Great, thanks, Amy. Let me just pull up the slides here. Great, so the first couple slides that I'll show may be redundant for those who have seen earlier presentations about Pangeo Forge, but I'm just going to quickly run in hopefully less than 5 minutes through a brief introduction to just frame what we're going to be speaking about, and then I'm going to hand it off to Rachel to get into the details of the tutorial. So we'll be speaking today about Pangeo Forge, which is a platform for transforming archival data into analysis-ready cloud-optimized data stores. This work is funded by the NSF award linked here. For much more detail in terms of motivations, architecture of the platform, et cetera, there is a published paper in Frontiers in Climate, Technology and Code paper at this DOI. And these slides are available at this link here. And I think we can definitely drop the link to these slides in the chat as well. So just going to anchor up this conversation to an actual data set. It helps kind of frame what we're looking at, which is the NOAA OISST data set, which is available from NOAA over HTTP and is organized into monthly directories with daily netcdf files. We can download a single one of those daily netcdf files with wget and open it with Xarray and see that a single file is about 16 megabytes in memory. It has a single time step of the sea surface temperature data. The problem, which is very familiar to everyone here, of course, is that this full data set is in excess of 14,000 files and would be somewhere in the range of 240 gigabytes in memory. And downloading all of those files would become quite tedious. So the old way, which we're kind of in our own opinionated way saying is the old way, is manually converting all of these files to Zarr with some custom scripts in your programming language of choice, maybe Python. But the manual Zarr conversion has at least 3 categories of problems that, that we can identify. One is reproducibility. From a scientific perspective, if we use a custom script to do this, then when future scientists or analysts want to check our work or reproduce our results, that script may not be accessible or discoverable to them, or even if it is, that script may not, the entire environment may not be preserved such that it can actually be rerun. There's also a problem of scalability. A lot of these data sets that we want to work with might be very large. So if we use custom scripts, they might not really be optimized for parallel execution, and they may not have good scalability. And then the question is also kind of tying primarily back to reproducibility, is how are we going to maintain these scripts if they're just one-off or more bespoke to the data set. So our solution that we're proposing is this platform Pangeo Forge, and that really should kind of, when we think of that, kind of divide into 2 categories. One is an actual Python package called Pangeo Forge recipes, and that package encodes the complete ARCO data transformation pipeline as code, which can be version controlled. And we'll look at that more in a moment. The other element of this is Pangeo Forge Cloud. And so Pangeo Forge Cloud is a lot of different modular components which provide automated recipe execution on the cloud and are also integrated with GitHub. And again, we'll see that later in the presentation as well. So to just zoom in a bit on a particular recipe, I'll actually just pull this up for your reference here. So you can see, oh, that link is no longer active. I will correct that in slides, but we'll be looking at this exact recipe in a moment in Rachel's section. If we import a recipe which is a Python module into this notebook, we can kind of see the way that it, as we said before, encodes the ARCO data transformation pipeline. And we can see that it looks at and sees all of the source URLs for this OISST dataset, but also attaches an index to them, which provides a numerical position and also a combination operation, in this case, concatenation over time. So these recipe modules exist in relation to the cloud architecture, like we said before. So when we have one of these recipe modules, that can be passed in to what we refer to as a bakery compute infrastructure. So bakeries are what are used to process recipes. And once that's happened and the recipe itself is executed, that process pulls the source data from the traditional data archive. In our example, that would be the NOAA HTTP server, performs the ARCO data transformation in a very highly parallelized, scalable manner, and deposits the resulting data into a cloud bucket for access by the user. For this particular data set, that transformation has already occurred, and we can load it directly from the Pangeo Forge S3 bucket on Open Storage Network, and see that, of course, as we're all familiar, probably in this group, when we lazily load a large Zarr store, it can very quickly give us access and visibility into, the full 240 gigabyte data set with 14,000 plus time steps for this data set. So that's just a very high level overview of Pangeo Forge, of just showing the documentation link here. Apologies that that recipes link was not active, but that's actually the part that Rachel is going to, oh, thanks, Rachel, link that in the chat, is going to now talk about is how you would actually make a recipe. And I'm going to, once Rachel has spoken about that, circle back at the end and talk a bit about the GitHub integration for submitting recipes to our bakery cloud infrastructure. So with that, I'll hand over to you, Rachel.
Great, thanks, Charles. I'll pause for a sec. Does anyone have any questions I want to jump with at this point?
Hey, a quick question, Charles, actually. Can you talk briefly about your bakery compute infrastructure? Very brief, just curious.
Yeah, so the bakery compute infrastructure, so every component of Pangeo Forge, and this is discussed in greater depth in that academic paper that was linked in the slides, but every component of it, Pangeo Forge, is meant to be replicable and modular. And so I can actually just provide a link. There can be bakery compute infrastructure built on any of the major commercial cloud providers. The link I've provided here, the bakery that we currently operate with our NSF award at Columbia University, is on Google Cloud. And the link I just provided in the chat is the repo from which that infrastructure is deployed. So there's a Terraform configuration in that repo that shows how we've deployed that, and certainly invite anyone here to raise issues or questions on that repo. It's definitely, as with everything, always a work in progress as well.
All right, thanks, Charles. We'll take a look at the Terraform. Thank you.
Sure.
Okay, nice. Thanks, Charles. So what Charles now has just kind of gone over and through the sort of Pangeo Forge recipes and Pangeo Forge Cloud, these pieces of the full Pangeo Forge ecosystem. Now, the piece that most people would interact with would be the recipes. So creating a recipe or defining how you might transform your archival, your traditional storage format to a cloud format. So what I'm going to walk through, take maybe 20 minutes or so, is walk through the process of creating a recipe. So Charles will share in the chat the link to a sandbox. And so that's what I have up on my screen. So I have two screens right now. Someone jump in and call me if you can't see it, but I'll assume you can. And so on one side, we have the sandbox, which is just a blank notebook, and that we'll be able to type into. It has Pangeo Forge recipes installed. On the other side, I have the tutorial, which I will just show how we're walking through is this introduction tutorial, which is available in the docs. We can also provide a link to that. So we'll take that OISST recipe that Charles was just talking through and convert it in the notebook. So I encourage anyone to follow along in the sandbox that would like to. And I should also say here that if you have any questions, as Charles said in the beginning, feel free to throw them in the chat and Charles will answer, or we'll talk about them as a group if anything comes up in that respect. So we're making a recipe now that we've come to here. So a recipe is, in the end, it's a Python object. That's the goal we're looking for here. So OISST is a sea surface temperature data set provided by NOAA, and we are going to convert it into Zarr. So at the end of this, we'll have some Zarr OISST data in the sandbox. So as a part of creating a recipe, the really big thing that we'll do first is create a file pattern, or I should say really big is maybe strong, but where a lot of the abstraction happens in a recipe is in defining of this file pattern. And that is to do with kind of the structure of the data. So what a file pattern contains in it is basically everything about the structure of the data you're converting and everything about the structure of the data where you want it to go. And that all gets mushed together into this Python object. The file pattern then becomes the recipe. So in terms of creating a file pattern, the first thing we want to do is think about what is the structure of our existing data. So for OISST, the link in the tutorial notes will bring you to this which is where it's currently stored. And by clicking around, we can sort of see that OISST is organized by month and then has files that are individual days. And that is perhaps familiar to you if you've worked with data such as OISST before. We could represent it using this image here, so that I'll make this side bigger, where we have files, individual files by day, and folders that have a month and month in them. So thinking through, or kind of going through that URL, we could come up with a sort of a template, or gotta make that a string that would represent like a generalized way of expressing the URLs that store OISST. It will look something like that. Yeah, is there a question?
Yeah, sorry, I'm
Please.
just making sure I'm on the right place. So when you click the link, I'm on a recipe.py and a meta.yaml. So should I go ahead and open a new notebook?
Thanks, Amy. Yeah, you can for now, yeah, totally close those out and open up a blank notebook.
Okay.
Thanks for that. Okay. So, great. So did that make sense then, Amy?
Yeah, I think, does anybody else want a minute to sort of, I guess, catch up? So we're pasting the link. Maybe just go back to like the first step again.
Totally. Okay. Totally. So what we've sort of done is this. So this first step is a little bit conceptual. It's like, what is the structure of the existing data? So this image on the left side is sort of a like visual representation of what OISST looks like, where we have individual files by day. And we might take that and then describe the URLs that we'd use to access data with something that looks about like this that I'm highlighting here, which is what I just copied and pasted in. So it's a URL, but it's not like it's a URL that's it's been generalized, we'll call it. So I've taken out the part of an individual file's URL where you might type 1981-12 to represent December and 1981-1209 for that specific date, and just put in this like format with this curly brackets that says year, month, and year, month, day. Does that make some sense?
Yes, and I think we just need maybe a link to, oh, there it is. Okay, the introduction tutorial. Perfect, thank you.
Awesome. Thanks so much for getting it all organized here. Okay, I'll pause there for a minute then, since it sounds like folks are getting set a little bit. So then one side I have this intro tutorial, on the other side is the sandbox, and the sandbox is a blank notebook in that sandbox environment.
So
Anything
quick
else?
question,
Please.
Rachel. So the sandbox, is this sandbox accessible? I'm not able to access.
Sorry?
Is the sandbox accessible for everybody, or?
Should be.
Yes,
Is
I was
it-
able to start one.
Yeah, so Sudhir, if you, I'll put it again. The sandbox link there, if you click the launch binder in the README, you should be able to open into a binder
Okay,
environment.
thanks.
And then maybe I'll just, for the really slow among us like me, we're on the introduction tutorial. It's not the Python in there.
Yeah, it should be, oops, okay, it should be the link that Charles put in. I'm putting it again in, but if you're following, I think you can follow along there. The Pangeo Forge, read the docs. Do you see that link in the chat?
I've got it.
Cool. Should we pause another moment or find to give it a second and then well, so I'll sort of summarize here to kind of reorient us. So our intro tutorial, as we said, we're creating a file pattern. So we're on the goal, our very long-term goal is that we're trying to create some Zarr data. The step to doing that will be this first step that we're on is creating a file pattern, which is the thing that's going to store the information about what our data looks like, the existing data, the net that's starting as a net CDF file, and also the output data, the Zarr data. So the first step to doing that was to consider what our net CDF, our archival data format looked like. And we did that by creating this URL template string, which is this long string that I've copied into the notebook that has the curly braces in it for the places where the URL changes by file. Okay. And as I keep going, so I'll keep moving. If you have more questions as I go, please feel free to throw them in the chat or jump in, either one. Okay. So the next thing we'll be doing is so in the next step in terms of creating our file pattern object is that we are going to be, our file pattern is going to be sort of organized of two things. We're going to have a combined dimension and we're going to have a format function. So I can even type that out here. We're making a file pattern and that's going to have a combined dimension. And it's also going to have this format function. So this is our goal. And so we'll do each of these things. So first we'll do our combined dimension. So the combined dimension is our way of thinking about how the files in OISST are going to stick together. So one of the things that we noticed when we made our generalized URL, or when we were looking at this figure up here, is that an individual file corresponds to a single day. And so the dimension that we are trying to combine our files over is time. So that might be intuitive to folks who've done this before, if that is the case, but it's worth kind of noting explicitly because as you get into perhaps more complicated recipes, the combined dimension may or may not always be time. So with our combined dimension, we're thinking about time. And the other thing that we are wanting to define is what time is it that corresponds to every single one of our files. So time is the thing we're going over, and what time is it for each file. So what we want as our next step is to create a list of all of the times that correspond to the files in our data set. So to do that, I'm going to use pandas. So I'm going to import, pandas. And use the date range function to describe the dates of our data set. So date range. And this data set goes from September 1st, 1981, and it extends until January, or sorry, it continues through present day, but I'll just end at the beginning of February, for example. And the pandas date range function also takes a frequency input. So I will use D for day. So what we get out now is this list that has a list of dates one day at a time through the range of our data set. So I will call that, I'll assign it to a list or a variable and call it dates. Nice. So that's the first part of our combined dimension. The other part of our combined dimension is just a string called time. So now that we have this together, we're ready to create our combined dimension. So here we're using a concat dim. It's concat dim and merge dim, so similar to the Xarray versions of those, if you're familiar with that. And that concat dim will import from the Pangeo Forge libraries. So from Pangeo Forge recipes patterns, import concat dim. Right. And we will create a concat dim object, and we'll have three inputs, I suppose. One of them is the word time, as we've been saying that's the dimension we're concatenating over. And the next is our list of dates. And the other thing that we will tell concat dim is how many items are in every file. So n items per file equals 1. That last one is optional, but it's a nice hint to give Pangeo Forge. So we can run that, and we'll get a concat dim object. And I will also assign that to a variable, time concat dim. Great, so we wanted our combined dimension, and this time concat dim variable is the time dimension. Nice. So next up, we will work on that format function. So I'm scrolled over on the left in the tutorial down to this image. And so what we want out of our format function is something to take the dates that were part of our combined dimension and give back the URL to actually go to where that data set would be for that particular date. So what we want is a data set where we're going to give it a date and it's going to give back a URL. So to do that, we can use the format function or the format string that we copied in above, and also the strf time function as a part of Python. So I'm gonna recopy this string from above, and I'll do it, try to make it a little more readable. So I'm gonna break it into a couple of lines here. And then, so here we just have a string. In Python, when we put the letter F in front, we can change this so it's no longer just a string, but something, right, that we can use variables to define as we for year month and year month day. So we can define year month to be 1981-09, for example, if we want to pick that, and year month day to be 1981-09-01. And now we can create a format string again for September 1st. So to make our function, we'll write this into a function and we'll call our function make URL, and what we'll want as an input is a time. We'll want to fill in year month with the formatted version. So we'll want to fill in your month and your month day with the string formatted version of the dates that we'll input. So time.strf time. Year, month, day, time, strf time. And this format string is what we will return from our function. Okay, so here we have our function. We can test it out if we want. We can take, for example, like the second date, September 3rd, in our dates list, and put that into make URL. And we get back our URL for that date. So that was the goal of that format function. So to kind of just bounce back up to the top again, we were going after a file pattern. We wanted our combined dimension. We wanted our format function. So we have both our parts, and we can make a file pattern. For a file pattern, we'll import a file pattern from Pangeo Forge recipes, and we'll use our two inputs for there. So from Pangeo Forge recipes.patterns, import file pattern. File pattern. We will have our format function, make URL, time concat dim, and that is our pattern. So there it is. We've worked really hard for that thing right there. It's, it's small, but it's mighty. There's a lot happening in there. We can maybe experience it a little more to make it a little more kinesthetic. There's a lot inside of that, right? It was everything about our input data set and our output data and the structure of that. So one way that you can interact with that a little more is you can actually loop through all of the files that are now contained that this file pattern is representing as a part of the data set. So for index and URL in pattern.items, we can print each of the pieces of this, both the index and print the URL. I'm also going to add just a little snippet of code here. You can run that if you, and it will run just fine. I'm going to put a little if statement in so that it stops after three URLs, just so we don't have 4 decades of output in this moment. Okay, so now that we've moved through file pattern, we're sort of seeing that there's a lot of text here that's come out of this thing. But what we're loosely seeing is in blue, we have the URLs. We have links to the actual data sets or the data files that we're interested in. And we also have these things that are these concat dims in here. And so these are the structures that are kind of defining the relationship between these files. So that's the file pattern. I'll maybe pause for a minute. Are there any kind of questions that have come up as it's been going? It sounds like there's a busy chat. So I don't know, Charles, anything you wanted to jump in with or other folks?
Most of the chat has just been trying to get people up with the sandbox. Looks like that's now happened. So there haven't been a lot of unresolved questions there that I'm following. But yeah, Rachel, this is all making a lot of sense to me, although I'm obviously biased here. So yeah, it would be a good time to jump in if the file pattern is not making sense in any way, which would be totally reasonable and understandable to anyone.
Could I just maybe summarize too what I think we're doing here, which is basically we've created a custom function make URL to list out all of the source netcdf files. So that's sort of custom to this specific data set, but in general, you could create any sort of function to return the list of source data files that you want to put into your file pattern, right? Object.
Yeah, I'd say that's fair. I'll let Charles and Ryan jump in, but I'd say it's totally fair that you're moving these files together. And you could use other types of like concat dim or merge dim. You could use like different pieces of the Pangeo Forge like recipes toolkit to combine things that like other structures of data, like more complicated than this one. Charles, do you have anything to add?
Yeah, I would just say, now that we've kind of covered through the file pattern and seen this formatting function called make URL, as well as the concat dim object that we made first, one way to think of it is we've made a function which, when given the keys that we passed into the concat dim as arguments, can make any URL we need for our data set. So the concat dim essentially like holds the arguments that we'll pass into our format function to make the URLs. And we're passing those in as 2 separate objects rather than, just one combined list altogether, because that is optimal for sort of the back-end machinery of Pangeo Forge. And I mean, one way to think about that is that 14,000 files is kind of a lot, but also on the scale of what we, hope to do with this is actually not even that many. So rather than creating a list of maybe up to hundreds of thousands of files, like we are passing in the tools that the backend needs to create any arbitrary file path by giving the arguments and the function as 2 separate objects, rather than giving a pre-assembled list of the paths.
And I would just add, like, it may seem like overkill at this point to use this like structure of like like maybe saying, well, why not just have a list of URLs, right? At this point, like, wouldn't that be simpler? And the real reason for this becomes evident if you want to combine along multiple dimensions in one recipe. Like, say you want to combine along time, but then you have many different variables you'd like to combine into one data set. That's the point when these abstractions that exist here become really, really necessary.
It's super helpful. Yeah.
Well, one quick question, just so when we're reading and creating this kind of a recipe, is there a way to reading like, you know, when we have even for NetCDF, there are like a specific standard NetCDF that you are looking for? Because, like, you know, in weather service we have several, like a legacy version of the NetCDF. Does that matter, or any recommendations on that?
The Swiss Army knife here of file IO is Xarray in this particular category of it. So if Xarray can read the file, then you're good to go. And Xarray can read a lot more than just NetCDF. So this works with GRIB files. This works with pulling data from OpenDAP endpoints. It works with GeoTIFFs via Rasterio. So really, actually, any file that can be opened by Xarray is fair game as for the inputs to this type of recipe.
Okay, all right, thanks, Ryan.
Can I ask just a real low-level question? So I know we were talking about gaps in the chat, but does this mean that we need to explicitly account for missing tiles and things like Landsat or Modus, or can we specify that date range and then just get the 404? And if you're going to touch on that later.
We don't have a good answer on that yet. That would be a perfect thing to open up an issue about in the issue tracker, because we would like to be able to handle that case. But I guess we're more focused on for the use cases we've been doing where we know that the data are all available for the data set we want to create.
Great. I think if it's all right, I'll take this kind of transition to kind of finish up the set about making a recipe and running it quick, so that we have a few minutes at the end for Charles to revisit the kind of cloud, the Pangeo Forge cloud piece of this, and a couple more minutes for questions. So with that, then we'll transition to creating and running the recipe. So I'm going to switch now to the second part of the tutorial, which will pick up right where we left off, which is creating a recipe object. So make a little header here, keep myself organized. Recipe. So this is what we've been going for. We started and Charles got really, was like, here, we're going to make these recipes. Recipes are an important part of Pangeo Forge, and this is how we make one. So we import the class and we use our file pattern to create it. So syntax for that: from Pangeo Forge recipes.recipes import Xarray Zarr recipe. So we're picking Xarray Zarr recipe so that we can have our output in Zarr. So our output will be in Zarr. After that, we'll define our recipe as equal to Xarray Zarr recipe. And we'll input pattern, which is our file pattern object that we just created. And we also tell it inputs per chunk is equal to 10. So what that second part is telling the recipe is that you will have 10 files that will come together into a single chunk of data in our Zarr store. And that's our recipe. Very long a repr that has a lot of information in it. But the biggest thing here that we could maybe see is we can see our file pattern object with all of the times, the 14,000 and so time steps that we had pulled together in our file pattern. So that was it. Compared to the file pattern, it was fairly quick. So the file pattern is where we are defining a lot of the logic of the recipe, and then creating the recipe from the file pattern is just that one line. With our recipe now, the thing is to run it. So let me pull up the little overview bit so that we can see it. Okay, so I have on this left-hand side the steps to running the recipe. So we'll do a couple of things. We'll set up logging.
Okay.
Sorry.
You are, sweetheart? Yeah. You say it?
So we'll set up logging. We'll do what's called pruning the recipe, and then we'll actually run it and we'll check the output. So pruning the recipe will be a step where we take this recipe that we made that is 14,000 something files long and make a much smaller version of it. I believe it will default to 2 files, and that will it's for testing. So when we're running you probably don't want, I don't think, in our sandbox, we want everyone making 14,000 files worth of OASST. So the pruning step is good for testing everything to make sure it's working well. Okay, so first we'll set up logging, which we will do, we'll say from recipes import setup logging, and then we can just run setup logging as a function, which will turn that on. The next thing we'll do is we'll prune the recipe. And to do that, we'll just take our recipe, and the function is copy _ pruned. I'm going to assign that to a variable called recipe pruned, just to keep track of them. And when we print recipe pruned, when we print recipe pruned, when we go back and look at that file pattern piece, we'll see that there's only 2 time steps there. So it's much smaller than our full recipe. If I were to delete the pruned part and go back to a regular recipe, we see our full time. And now that we have a recipe, we can run it, ! So there's a couple of ways to run things in Pangeo Forge. The one that we'll use here is we're going to basically take our recipe and we're going to turn it into a function. So this run function thing this variable I'm defining here will become a function. So recipe pruned, and then we'll say to function. And what's happened now is that run function is an actual, it's a regular Python function. So when we add the brackets, it starts running. So we're here. So we're seeing this is all the output of our logging, so we can see our recipe running. That's the recipe. To just quickly here give, I think, some kind of, show that how it's worked. We will use xarray to look at the output and see the data that we just created. So with xarray, we will say xr.open Zarr recipe target mapper. It's true. And we have our data. I'll call it OISST. Let's come out of the data set. And if we really want to see part of it, we can go into the SST and pick a particular point in time, just the first one. So there we have our data set. Our Zarr data store that was originally, half an hour ago, was in netcdf stored up and with Noah, and now is in your version of the sandbox, your binder link, and is stored in Zarr. And we did that by kind of defining this recipe in the file pattern chunk here. So I'll pause and actually kind of transition so that we can take kind of questions on that chunk, and then move back to letting Charles go back to kind of the cloud aspect of taking this recipe and scaling it up. So any questions, I suppose, on the recipe?
I see, Ted, you're raising your hand. Go ahead.
Yeah. Since these files are in netcdf, would it be also possible to write a recipe that used Kerchunk, say, to to access the files rather than copying them into Zarr or something like that?
Yes, so what was kind of glossed over in this tutorial is that we use the Xarray Zarr recipe class to create this recipe, but that's just one of, right now we have 2 recipe classes, and the other one is called HDF reference recipe. And if we were to use that class instead of the Xarray Zarr, and Ryan is linking to that in the chat, you would get a Kerchunk output rather than a Zarr output.
Part of the
Great,
reason
thanks,
that wouldn't
Charles.
necessarily be optimal here, Ted, is that these netcdf files are not actually in the cloud. They're on one of Noah's servers. So we may be able to create those indexes for them, but that doesn't mean we'll get sort of cloud optimized level performance, because we would still have to keep going through Noah's HTTP server, which is going to be a bottleneck here. So we do ultimately, for this source, we want to copy the data out of where it lives.
Yeah, thanks, Ryan. I was just curious in the general case as well as the specific case.
So I think in the interest of time, we'll still keep tracking questions in the chat, and I'll try to be as quick as possible so we still have time after this. But I'd like to just bring everyone's attention to the Pangeo cloud and particularly the integration with GitHub, just to give a bit of a preview for that. So everyone who set up their sandbox found hopefully this link, launch binder in the sandbox, and apologies that we're still a bit thin on this README, but that'll be added to shortly. So once you've launched the binder, Amy asked that very helpful question about, okay, wait a second, I'm seeing a bunch of tabs open on this screen. You could open a new notebook here with the launcher, as many of you may have already done to work on a tutorial. But the reason we've pre-configured the notebook to open to these 2 tabs particularly is that to submit a recipe to Pangeo Forge Cloud, you need 2 things. You need a recipe.py, which is what you're looking at in sort of a templated form here, and you need a meta.yaml. And so that the meta.yaml sort of talks about the provider provenance of the data and the license, as well as some other specifications like what version of Pangeo Forge you used to develop this recipe. And ultimately, these 2 files, a recipe.py and a meta.yaml, is what one would open as a pull request on GitHub. I'll just show an example of that and then talk about where we are here. So I'm just showing you a pull request for a different data set here that has a meta.yaml. It also has a recipe.py that's somewhat similar to the one we just looked at. Where we are right now, and this is a key point to remember, we're in Pangeo Forge organization and the staged recipes repository. So we've modeled this on the Conda Forge GitHub integration, where they use also a repository called staged recipes as the kind of intake point for contributions. In staged recipes, you'll see under the issue tracker, there's many proposed recipes. And if you have an idea for a proposed recipe and are not feeling quite ready to develop it yourself, we certainly welcome you to propose a recipe on the issue tracker. There's also pull requests, which are works in progress. And the one we were just looking at was for this SOTA 3.4.2 model output. This is one we've been working on for a little while. And we've opened a pull request here that has, again, the meta.yaml information as well as the recipe itself. And the main point I wanted to take away for everyone to take away is that once you open a pull request, we have something here called the Pangeo Forge bot. Maybe I can make this a little bigger. So the Pangeo Forge bot is going to essentially lint or look over and review the formatting of your meta.yaml and your recipe.py. In this case, when we first opened the PR, there wasn't a meta.yaml, so the Pangeo Forge bot identified that. once we added a meta.yaml, the bot realized that it was missing some required fields. And when we tried to do that, there was some errors with that file, which were identified as well. But ultimately, once the recipe.py and the meta.yaml are follow the formatting that the bot expects, that it will register that with our cloud infrastructure, and then a maintainer such as myself can begin the testing process of that recipe against the cloud. We don't have time to necessarily go into the full details of that now, but what I wanted to just highlight for everyone is that once you've worked on a recipe and a meta.yaml, or you've gotten as much of that as you know how to get started, opening a pull request on staged recipes is the way to start the process of bringing it into Pangeo Forge Cloud. I think I'll just pause there, and because we have a few minutes left to take questions and see if there are other questions. I guess to state maybe what might be obvious to many is one last point. The reason you might want it on the cloud, in addition to having it available to other people, as Rachel showed, we just executed only 2 time steps, but 14,000 time steps on your local computer would be pretty computationally expensive. So that's the part we're offering to be able to do as a community resource.
Will it also be possible to run this, or maybe have a tutorial in the future on how to set up your own infrastructure to run it? I don't know, for a given provider that might want to be generating, running their Zarr generation on their own resources.
I think in general, Ryan, I'll let you go into greater detail. I don't know how many of what level of broad interest that would be. I guess that'd be a more specialized audience. Ryan, I don't know if you see that as something that has enough interest to provide a full public tutorial on.
Can you repeat the question, Amy? Sorry.
I think I'm just wondering, like, it sounds to me like part of the Pangeo Forge scope of work is to set up the cloud infrastructure for scaling the Zarr generation. Is that right? So I guess what is going to be the sort of due process to requesting like, if I'm,
Right.
NASA and I want to generate a Zarr, use Pangeo Forge to generate Zarr, like, would I just be dependent on Pangeo Forge allowing me to do that, or would I be ready to set up my own bakery?
Right. I mean, so I guess just to kind of go all the way to the end of the discussion, what you're ultimately asking is, whose job is it to support sort of cloud data infrastructure for our field,
Yeah.
right? Whose job is it to pay for that? And the fact is, we have a lot of different agencies and organizations who are interested in supporting that and paying for that, but all in different ways for different user bases. We have funding from the NSF EarthCube program to support this resource, and for a limited time to operate these bakeries, store the data, working with Open Storage Network. We have quite a bit of storage space available to host community supported recipes. But certainly we do not have like the long-term mandate or funding model like a DAC to like maintain this infrastructure forever for all time going forward. And that's probably not what we're interested in doing as a academic research lab. So what we've tried to do is create a tool, a structure, this bakery that anyone could sort of join this federation and provide capacity. Right now, we're just at the point of trying to show people that, hey, it actually works. And I think the next step is to get users interested and create a community of contributors. And once that community of contributors is in place, I think then that's the time to make the case for more sustained funding and involvement of the agencies. Right now, it still feels like an experiment, to me.
Okay.
So thanks. I think, Amy, that's very relevant what I was going to further ask about. Some of the, we'll be interested to explore some of our water center data coming from water center and utilizing some of these to test. So definitely like in having our own infrastructure will be probably a way to go, but is there a sort of mechanism for collaboration where we can actually test some of our data sets in the Pangeo?
Yeah, you can come make a recipe and staged recipes today, and we can run it and get the data in the cloud and see if it works for your use case.
So that will be great. So we'll reach out, right?
Yeah, and I think that really just to emphasize for anyone here, because I know it's still like a new concept, that really Pangeo Forge, and I'll put the link also. Pangeo Forge staged recipes issues is the place to propose a recipe for your data set of choice that you'd like some help working on. And if you already kind of feel like you understand enough from this tutorial to start working on the recipe yourself, you can simply open a pull request with a draft form of the recipe for your data set, and the bot will take a look at it for you and make proposals as to what's missing or not missing. And because the bot is still learning, the human maintainers will also come in and, and help you with that.
I am curious also how it's handling authentication. That must be something that you guys have covered if it needs to.
How the bot is handling authentication?
Oh, no, sorry. How the remote, like a recipe execution, if it needs to request files behind an auth server, how we can pass.
Oh, right. Yeah, go ahead, Ryan. Sounds like you're about to answer.
I mean, to be perfectly honest, we've kind of punted on that for now,
Okay.
for the sake of getting to a minimal viable product. We're just trying to focus on pulling public data right now. We do have the ability to pass secrets through to the file patterns and use, for example, Earth Data Login or any other common sort of authentication system. But what we don't have in place is a really robust way to sort of manage those secrets on behalf of users. So you can use the Pangeo Forge recipes library today, like on your laptop, and just pass, or on your server, and just pass in authentication, information and run it in your own sort of domain perfectly safely. But what we don't have in place is a system for managing your secrets within the cloud platform, which is a sort of much more complex and potentially risky scenario. But that's where we intend to go. We want to have that system in place.
Okay, awesome. Well, we're almost at time, so I just wanted to wrap it up. Oh, Matt, did you want to say something quickly?
Yeah, I had a quick question and a comment. Yeah, I've been sort of somewhat following this Pangeo Forge stuff for a while, but wasn't quite sure how it fit in with everything. What happens if I scale this up and run it on a whole lot of files and 5% of them fail? How can I go back and rerun those or find out why those had failed? Is there any sort of error tracking?
Yeah, I'll try and answer that, Matt. That's a great question, and things do fail when you're at that scale, so it's really important to address that. Right now we have really verbose logging from this library that will hopefully tell us why things fail. So that's sort of step one. Where we're at now is trying to figure out how to route those logs all the way through the system so that if a recipe execution fails, like the recipe author can actually see that and find their way and try and fix it. Whether we want to actually be able to move forward with the recipe execution, even in the presence of missing data, I feel like is a design question and perhaps a configuration option that we want to give. So say to allow to just carry on, even though some data were not able to be acquired. I think that's a technical conversation that we would love to have on the GitHub repo, especially if you have a specific use case in mind.
Okay, cool. Thanks for that.
Kind of related to that is the question I asked in the chat, where you may want to run like a model later, like the data is missing and you want a uniform time base with nans in the data, so you can go back and either insert that data later or maybe even update some part with a better simulation or something. I guess that would be, interpolation or something onto the. I'm not quite sure how that would work, but Is that something that could be done in this framework too? I mean, I'm sure it could, but
I mean, I think it's something that's not implemented right now, and then anything that's possible in Python is theoretically possible. So I think that for all of these points, it would just be, taking, whether it's Matt with your question or Rich, I just really can't emphasize enough how much we would appreciate just raising, sort of open-ended feature request or feature question issues on the main issue tracker of the Pangeo Forge recipes. I'll put that there. Even just, 2 minutes, just say, hey, we went to ESIP and we talked about this. I think that if something gets registered there is the most likely place where then it ultimately becomes a feature.
okay, I will definitely do that. It's a real use case that's been killing us.
I want to read Ryan's message. There are a million edge cases here. Right now, we are trying to write code that will have the most bang for the buck in terms of converting 80% of common use cases. Yeah, I mean, I think this will segue nicely into kind of what I wanted to say as a wrap-up comment, which I would also leave open for Charles and Ryan to make any wrap-up comments. But I think this is like a really important example of sort of like open science and open source collaboration in action, where you guys have started and are working on something that's like really great and can be collaborated on with like many people from the community. And starting this tutorial here with this set of people, I think we can sort of, start to sort of like, with Rachel's tutorial, now I understand Pangeo Forge a little bit better, and I can go teaching other people how to use Pangeo Forge and sort of spread the word in that sense and get that greater community contribution. So everything that we've talked about here, I just think is part of sort of like the greater effort on this project. So I really appreciate everybody's questions and attention, but I don't know, Charles and Ryan, if you want to add anything, or Rachel.
The only thing I would add, and leave it to Ryan and Rachel for anything else, is I just put a link to our OSM session, which is on Friday. So that's going to be a 2-hour version of this same material, and also one in which we've had 4 more days to improve the documentation. So if you're interested at all and you'll be planning to attend OSM, we'd love to see you there as well.
Awesome. Well, we're way over, but Rachel or Ryan, anything else you want to add before we close?
No, feel great. Thanks for having us, and look forward to folks, kind of raising issues and jumping in on the GitHub. Look for that.
All right. Thanks so much, everyone. Thanks for joining.
Thanks a lot.
You stuck around.
Thank
Bye.
you.
Thank you.